Our galaxy is over 100,000 light-years across. A distance so vast that it defies ordinary understanding. Even humanity's earliest radio transmissions hurtling through space at the speed of light would still only have washed over less than 1/1,000,000th of the stellar population. The cosmic speed limit, the speed of light, is so diminutive compared to a galaxy that any aspiration we might harbor for galactic exploration or even just communication seem impossible, at least within human lifetime. But humanity has long wondered, could there be a cheat code? Could there be a way to exceed that cosmic speed limit? Could we go faster than light? FTL. There is no other technology that I so keenly wish could be realized than FTL. Since childhood, I've looked up at the stars and dreamt of exploring the ocean of space, the zoo of world, the menagerie of life. It almost seems like a cruel cosmic joke that the universe be arranged in such a way that we are able to look out and glimpse its wonders and yet are trapped here by the speed of light. Fated to any other peer through the bars of our cosmic prison and dream. And so it's no surprise that human ingenuity and aspiration has ragged against Einstein's cosmic speed limit. After all, we've never been so good at doing what we are told. To be clear through, we currently have no way of building or even conceiving of a practical FTO system, be it for travel or just for communication. But there are threads that physicists pull out that it is hoped one day might bear fruit. For example, we know that Einstein's speed limit only truly applies to travel through space, but that space itself has no such constraint. For this reason, there are parts of the universe receding away from us faster in the speed of light as the fabric of the cosmos itself expands in all directions. Could we one day learn to manipulate space then and somehow use this travel faster than light? The hypothetical alcubierre drive is perhaps the most famous example of this concept. Inspired by Star Trek's warp drive, Miguel Alcubierre showed that there exists a solution within Einstein's relativistic field equations that in principle could allow FTL. By expanding space behind itself and contracting it ahead, a bubble of space could cruise between in the stars at arbitrarily fast speed. The idea has certainly faced many challenges thought, such as requiring the use of exotic matter, enormous energy requirements and even obliterating the destination through the building of radiation gathered up by the bubble. Yet optimists might argue that none of these are truly showstoppers, merely engineering challenges. A more pressing problem is folding in quantum effects into the alcubierre drive. In 2009, Finitzy showed that the warp drive bubble leads to exponentially increasing Hawking radiation on the inside of it. This isn't just a hazard to their crew, the exponential buildup destabilizes the bubble itself. It's important to remember that we don't have a good theory of quantum gravity yet. And alcubierre drive is conceived in its absence just using general relativity alone. These kinds of quantum concerns don't just plague warp drives. Wormholes, another hypothetical FTL system, has also been criticized as being possibly unstable due to these quantum effects ignored by general activity. Ultimately, we can't truly prove whether wormhole or alcubierre drivers are allowed or not, whether wormhole or alcubierre drives are allowed or not until we have solved quantum gravity or built a working example of one. The other problem with assessing the feasibility of FTL is that there are multiple ideas out there such as tachyons, Krasnikov tubes, quantum tunneling and entanglement. And each one of those has a driver's number of flavors proposed. For example, the alcubierre metric has been tweaked many times to reduce the energy requirements in various ways. And of course, physicists still surely will continue to conjure up new varieties in the future. As a result, it seems somewhat hopeless that we'll ever be able to completely exclude FTL as a possibility. On the hand, our hearts might rejoice in that because it means that persists and the dream will always be alive. But on the other hand, our minds complain because after all this is science and we want definitive clear objective answers, not eternal maybes that will forever be unfalsifiable. So is there anything that we can definitely say with existing knowledge? Well, it turns out, yes. The explanation is a little challenging, so we're gonna break it down into small bite-sized steps and use diagrams to help us understand it. It's worth spreading a little bit of time on this because the consequences are truly profound. Let's start by drawing a line representing one dimension of space along the bottom of the screen and a line representing time that's orthogonal to that. We now have a space-time or Minkowski diagram. To get acquainted with this setup, let's consider a distant star like Vega. This green square represents Vega at a certain point in space. In other words, its location but also at a certain point in time. Let's consider that Vega is stationary in this frame of reference so that as we move through time, it traces out this line. Note how it has the same position at all times. This line is what we would call the world line for Vega. And we don't have to limit ourselves to just Vega, we can for example, put the Earth on this pass-time diagram as well. Earth isn't moving much compared to Vega, so let's just assume it's also stationary in this frame and thus has a parallel world line. Since we're ultimately interested in speed when it comes to FTL, let's now familiarize ourselves with what speed looks like on this diagram.